Hi folks, and welcome back to another video. Today we're going to take a look at Boolean Algebra. So without any further ado, let's get started. Okay, so firstly, I'm going to discuss a bit of what is Boolean Algebra, if you might not have known. Well, in the 19th century, George Boole defined an algebraic system for true and false. So this system uses only true and false, so 0 and 1. So let me zoom in on that so you can better see. So it uses only true and false. Now, you might ask yourself, when would you like to use a system like this, and why would you like to do something like this? Well, when you're writing code, you have if statements, which inside have a condition. For instance, if a number equals with something, or a while condition that uses a similar condition, or a for condition, or anything that uses a condition. So these conditions in the end are just going to have a value of true and false. So sometimes it's not all that great. So you don't have just a function that returns true and false, and you don't have just a simple expression like just something that equals to something or something is greater than something. You might have complex expressions made out of multiple statements like these, equals with or it's greater than. So you might have something complex. For instance, if number equals 4 and also let's say number 2 is greater than 0, or let's say number 3 is greater or equal to 2. So in this case, it's a bit more complex, and sometimes you might want to simplify something like this to its shortest form. You don't want to keep all of these individual conditions and clutter your code with all these kind of stuff. So this is what we're going to discuss today, and I'm going to start by explaining some simple rules. So there are a few operators into Boolean algebra. There is not, so there is not, and I'm going to say them in the order of precedence. So there is not, then there is and, then there is XOR, and then there's OR. Now, there are many more like NAND and XNOR and NOR that basically are just negations of ANDs and ORs and XORs. And we're not going to get into those because that's not what you're going to use in code. You're going to use these operators in code. XOR might not be familiar to you, and I'm going to explain in a little bit what that does, but these are the ones you want to focus on. Okay, so now that you know what operators are in, let's discuss what each of them does. So not A is really simple to explain. It's like if it's false, then not A is going to be true, and if it's true, it's not going to be false. And would mean that both of them are true. So both A and B are true. So that means that if I do have two conditions that form an expression like these, if both of them are true, the whole expression is true. Else, if at least one of them is 0, so it's false, the expression is not going to be true. XOR is exclusive OR. So what this means, it's basically if they are different. So if A is different from B, then it's true. So this is what XOR does. And OR means, so if you have A or B, that means that at least one of them is true. So if A is true, then the whole expression is going to be true. If B is true, the whole expression is going to be true. If both of them are true, it's going to be true. And if none are true, then it's not going to be true. But you might already know these operators if you coded. And we're going to look in their properties. That's what the George Boole's system was mostly for. And also De Morgan has some laws that are really important and that are used. So first of all, what you have to understand is that for the OR operation, false is neutral. So if I have A or 0, then this expression is going to be just A. Assuming that A is a Boolean type variable, so it holds only true and false. So all these A's and B's are going to be just Boolean type variables that are holding true and false. So also, just a second, for XOR, false is neutral. So I need to think of this. So A XOR false. So for the simplicity of it, we're going to note false with 0 and 1, and true with 1. So this is going to make it easier for us to see everything. So false is neutral for XOR, for exclusive OR. So why is that? Because if A is different from 0, the expression is true. And if A is different from 0, that means it's 1. So it's true. So if it's true, the expression is true. So also false is neutral for exclusive OR as it is for OR. Now, for AND, true is neutral. Because if you have A and 0, then it's going to be automatically 0 because they're not both true. Else if it's 1, that only if the other one is false is going to be false. So it's dependent only on A. So that means that only A will be simplified to it. And a few more rules to understand is that, and which is derived from this and from the fact that A or 1 is going to be 1. So let's write this down. So A or 1 is going to be 1 by default because you have at least one that is true. And you don't have a variable to prove that. You really just have it. It's true. So the whole expression is going to be true by default if you do have something like this. Also, if you have A and 0, then it's going to be 0 always. A and not A, let's use some parentheses to show the fact that this is isolated a bit. So this is going to be 0 by default because A is going to be different from not A. So what that means is that one of them is going to be 0, and that way the AND condition is going to be void and it's going to be false by default. Also, if you have A or not A, that's going to be 1 because, as discussed, one of them is going to be 1 and the other is going to be 0. And as such, by the definition of OR, it's going to be true. And it's going to be this thing because that's how it works. because if you have not A and A, if this is 1, this is going to be 0, and you get to this point where one of them is 1. Else, if this is 0, then this is going to be 1 because it's not A, and again, it's going to be 1. So it really doesn't matter. As well, if you have A XOR not A, that means they're by default different, and as such, it is true. Now, let's get a bit to something a bit deeper. So, let me think what we're going to do first. Oh yeah, and also it is commutative, so just like in normal algebra, A and B is going to be equal to B and A or B is going to be equal to B or A, and so on and so forth. Now, these three are binary operators, so they take two numbers to complete the expression, two values, as you might see here, while not is a unary operator, so it takes just one thing to return a value. So next, it is distributive and associative. So if you have A plus B plus C, then this is the associative part. So as such, A plus B plus C. Also, the distributive property says that A times B plus C is going to be equal to A times B plus A times C. One thing to note is that all pluses are going to signify ORs, and all multiplications are going to signify AND, because they have common properties. So anything times 0 is 0, and if you use plus and multiplication, so addition and multiplication, just with zeros and ones in normal algebra, you're going to have very similar properties. So that's how we're going to note AND and OR, with plus and star. XOR, I hope I do have that symbol in here. More symbols. So I hope it's here. Okay, it's not here, but we're gonna use that as a word then. Okay, the next properties are De Morgan's laws. So what this states is that if I have not A or B, this is gonna be equal to not A and not B. So if I have a not, it's going to not both of them, and then it's going to change the AND in an OR and the OR in an AND. So if I have not A and B, then it's going to be equal to not A or not B. So this is De Morgan's law, both of them. They are quite the same thing. Also, one thing to note is that if you have A or A, it's going to be equal to A and A and A, it's also A, and that not not A is also A. So these are quite the properties that you're going to see in Boolean algebra. So as an example, if you're writing some code and you have multiple properties, let me think of something. Oh yeah, and how you open up the XOR into and or. That's what I haven't showed you yet. And this is very important because languages like C++ don't have a XOR operator, and you have to do it yourself. So how would you do A XOR B in, let's say, C++? Because there is no exclusive or operator. So if A is different from B. Now, of course, you might want to do this, or this is how you would write it in C++ if you have two expressions, but that's not the right way to do it. So the right way to do it is to do not A and B, or not B and A. Now, the order of precedence is and then or. So if I put some helping parentheses for you to see it better, this is how it would look. So not A and B, or not B and A. This is how you would put XOR into, if you would put the conditions. So for instance, if I have a piece of code and I do, let's say I have these two expressions. So I have, you know what? Let's fire up CLion. Okay. So, okay, I'm going to zoom in a bit. Cut this line. So now let's say I have int number 1 and number 2. Okay, and I do, and I'm going to input two numbers. And let's say if I want to have them, that one is odd and one is even. So that would mean if, and the two expressions are going to be number 1, the remainder by dividing it by 2, one is 0, and one is different from 0. But how would you do this as two separate expressions so it's now you might want to write it like this, but this is not a good solution, because if one of the numbers is negative, so we're going to just prove this. Okay. And if I can prove this, so I go here, and I run the program, and if I put two numbers that are both even, but one is negative and one is positive, it would give true in certain conditions, because it sometimes can be -1, the remainder. Mathematically, it's not possible, yes, but code works different. So you might have some problems. Yeah, because they were both even, both of them were 0, so they were equal. But if I would put minus 3 and 3, so they're both odd, so they would be different from 0. So the remainder would be -1 for this and 1 for this. Watch this. So this is true, but they don't. It's not one even and one odd. They're both odd numbers. And why is that? Because even if mathematically it's not possible, the remainder by 2, it's going to be -1 in programming. And you might want to combat that, so if it's different from 0. So number 1 is different from 0. That means this is odd. And the other one is even. So this is equal to 0. But this is not all. So let's say that we want to test their this thing. So we're going to do equals to 0. I'm going to not the whole expression because it's going to be easier for you to see the XOR in it. So and number 2, okay, or number 1 and number 2, and this whole thing is going to be not. Now, what C-line wants is to place parentheses around the whole expression. This is all it wants. Of course, it wanted to just automatically simplify this into it's different, but I want you to see the XOR. So what happens here, if I'm going to put this side by side, okay, I'm going to zoom out. You're going to be able to see one thing. So this is going to be expression 1. So this is going to be A, and this is going to be B. So look, not A and B, or A and not B. So this is how you do XOR. So exclusive OR, so that they are different. So if they are different. So if I'm going to run the program, I'm going to do -3 and 3 again. It's false. But if I'm going to do -2 and 2, it's false. If I'm going to do 2 and 3, it's true. If I'm going to do 3 and 2, it's true. And if I'm going to do, let's say, 1 negative and 1 positive, it's also true. So now you can see it works properly. So the XOR works properly. And this is why you wouldn't want to do, so if I'm going to comment this line, I'm going to do the if again. Number 1. So you might be tempted to do this, but this is not correct because look now, if I do 2 and 3, it shows true, and if I do 3 and 3, it shows false. Okay, that's perfect, but what if I do negative numbers? If I do -3 and 3, it should show false because they're both odd, yet it shows true. Why is that? Because these two are indeed different, even though if mathematically it's not possible. In program it is possible, and this is going to be -1 and this is going to be 1. So they're going to be different, and as such the expression is going to be true. So you don't want to do this. What you want to do is XOR, an exclusive OR. And if I would write in code all of these, yes, you can simplify all of the expressions into code by using these laws, where A and B are expressions just like this one. So now the video is getting a bit too long, so I'm gonna end it here. So yeah guys, thank you for watching. If you enjoyed this video, give it a thumbs up, and if you want to see more, click that subscribe button. See you next time on HowToIT.